And we push record, and here we are. This time around, we're talking with Jim and Bob. It feels like a 80s radio show couple or something like that. Personality-wise, they weren't quite there, but it was really a fun conversation. And so we're going to talk about Rust. Not the kind because your bike was sitting out in the water too long. We were actually going to talk about the language, and actually we're going to go quite a bit further than that. But before
this
we do
isn't that movie either. Not the.
This isn't the movie that. Yeah, I forgot that. What's his name got sued for or ended up in jail or whatever it was. None of that. And if anybody wants to complain about it, talk to Michael. I don't know which way he is on these windows. I had nothing to do with that. This is Building Better Developers. This is the Developreneur Podcast. I am Rob Broadhead, one of the founders of Developreneur, also the founder of RB Consulting, where we help you avoid expensive technology mistakes before they happen. We help you help guide your leadership through the AI and technology projects that you're running into before you get into them, so that success is actually now only a few steps away instead of us going in the wrong direction. Good thing and bad thing. Good thing is, I'm going to actually say good thing is AI. This is one of those things is because it sort of comes from a bad thing, is that I have been very busy doing things that weren't some of the work-related stuff. So things backed up a little bit. And I've talked before about Chip and some of the automations and things that I've done to help me get my daily work done faster. And AI definitely was critical. The bad thing was that I had a bunch of stuff piled up. And some of it's the kinds of things that you really don't need them to pile up. If you're trying to return an email or something like that, those kinds of things you want to you need to keep up to date. But the nice thing was that Chip allowed me to quickly catch up the things I needed to. So when I was able to actually go heads down again, I was able to get myself more or less back on track. Just like eventually getting to the end of my introduction and allowing Michael for his.
Hey everyone, my name is Michael Malash. I'm one of the co-founders of Building Better Developers, also known as Developreneur. I'm also the founder of Envision QA, where we work with businesses to fix their systems and replace the guesswork with tested, dependable solutions built around their business. That could be helping you automate some manual processes or figuring out some bad software. We'll help you with that. Good thing, bad thing. Good thing it's another Friday and another week down, and things are still moving forward. So very happy about that. Bad thing, even though you got a vacation a couple weeks ago, I really need a break from everything because I have not been to my river house once this season, and the weather has been so nice. It is I want to be out there. And it's no, I'm stuck in my office, stuck at a computer.
Trust me, if your vacation is like mine, don't do it. Don't do it. It looked really good from the outside, and it was not. It was a big mistake.
So I just want to flip that sign and go fishing. Literally go down the back of my bank and just go fishing. I haven't been fishing in months.
Just get the old PlayStation where we do that kind of fishing, or find something else. Trust me, just keep it very simple, very short. So we talked with Bob and Jim, and this week we talked about Rust, the language, and why it's got value and why it's becoming important. And it's a very interesting conversation, I thought, to have right now, because we are actually, when we have been saying for a while, don't bother with languages. Languages are not, your key to success is not going to be a language anymore, because a programming language, because AI is going to get you there faster. The things that matter are design and architecture and things of that nature. The interesting thing is Rust forces you into better design, better architecture. And by you, that also means AI. Now, it's not as old and prevalent as languages such as Python and PHP and Java and C and C++ and C# and those that the LLMs are trained on those languages. They kick butt on those. They can crank through them, not a problem. Rust, it's getting there, as they said. We're getting a little better with it. But the interesting thing in this that I wanted to bring out is that it was interesting because this actually took us back a little bit, because now Rust is a compiled language. And we haven't talked about those in a while, because everything, JavaScript is interpreted, Java, even though you've got the JVM and stuff like that. PHP, Python, these are all things that I guess they're pseudo compiled or whatever, but basically they are not. They are, scripting languages, for lack of a better term, and they are interpreted. And it was interesting because it comes back to like, oh yeah, we probably should have some of those. We need to actually have compiled applications that are not interpreters, because if you play around with them even a little bit, you're going to realize that the interpreted stuff, especially when you start to scale up, is not going to be as fast and as efficient as the compiled stuff. And this is just, it makes sense, because the interpreted has got to do all of this stuff on the fly, whereas the compiled can actually tune it for what it needs to be done beforehand. All of the thinking work can be done almost before you get into the application. And so it was really fun to sort of go back a little bit to, a flashback of, to me, probably 20 or 30 years of really talking about the difference in these languages and the strengths that languages have that force you into a certain thinking style versus the weaknesses, we'll call them, of things that are, the loosely typed languages. And Python, I'm looking at you because Python allows you to like just crank stuff out really, really fast. So you could just throw stuff in there and it'll just more or less make it work. It will find a way to make even ugly stuff work. Work correctly is a different issue. And this is where I think it's very interesting when you're using AI and you can tell AI which language you want it to use, what stack you want. It may help you to pick something like a Rust stack, where it not only forces you as a developer, but like I said, forces the AI into something that is much more constrained. You almost have built-in guardrails, because if you're using this, if you're in this language, if you're building applications this way, the AI doesn't get to break the rules. It has to still follow those rules. And so you have less guardrails you have to set for it, because it's already been set for the environment. Passing this over to you now.
Yeah. Oh my God. This was like you said, going back like 10, 20 years, because I mean, when was it? Like once Node started coming out, once JavaScript started like exploding, and the iOS architecture got open, and you could really start writing in any language you want and deploy to any platform you wanted. We got away from the compilers. We got away from C, C++, and even some of the .NET compilers. And we're all JVMs. We're all interpreters now. It's all scripting languages. And you're right. As we went through this conversation, it's like we lost something there, right? We lost production. I mean, yeah, we scale, but now we got to buy more processors. We got to buy more RAM. Where if you're writing a compiler or writing code at machine language, you're tuning it for that machine. So you can do a whole lot more with that than you could with the scripting languages. It was a great conversation. It makes me want to go back and like learn a new language again, even though in the age of AI, we keep talking about like, languages are pretty much mute, because we can have AI do it. We can quickly, code is essentially just becoming here, go do this, build the code, fix the code, deploy the code. But we have to think about how we want to build it. So this is like a good exercise to get back into. Okay, let me go learn this language. Let me go take something I've built before and really think through this. So you're getting back into that less vibe coding and more building software from the ground up. Like, how do I do this foundationally? How do I build it? How do I stack onto it? So you got to build that like kitchen sink app to kind of understand, okay, what does the project look like? How does the code work and the syntax? And you build up on that. Ironically, it made me think back to my DOS days, back when you had to actually deal with high and low memory in DOS. We're old. We're getting old. So for those of you that don't even know what DOS is, it's your command line in Windows. But it essentially, you had to code for that. You had to actually, every time you ran a program, you had to configure your environment. You had to tell the machine how to do things. It didn't do it for you. And a lot of our conversation with Jim and Bob were around that. Some of the things they were doing with Rust, which was really cool, like memory management, ownership, borrowing, uh, the constraints, the strong constraints on variables and things. So you know what it is. Java does a pretty good job of that, but Java, like all interpreter languages, introduced var. So now you have no idea what type of value you're passing around anymore. You have to typecast things. So I love compiler languages for that reason. It's like you go look at it, you know what it's doing. The only caveat to that is you're not just tied to your operating system, you're tied to the machine, you're tied to the architecture. So you're tied to Intel chip, you're tied to ARM chips. So it's just one of those where you kind of get back into a different world of things. Now, I know it kind of ran for a bit, but I'll pass it back to you. Sorry.
I do want to say that's, I think they touched on some stuff that I hadn't really thought of in a while, but I think they are core concepts that is useful for everyone to understand. And the memory management and pointers are a huge one, because I think you really don't have those. You have a little bit of garbage collection, stuff like that in Java. You can use pointers in some of the .NETs and things like that, or at least you could last time I tried it. But you don't really have to think about them. There's libraries around them. And even C++, there are libraries to help you with a lot of that. But going back to the foundational stuff, I think is very useful. It helps a lot to understand the computer architecture underneath, to understand what memory structures look like and what it means, and how do you use pointers, and how do you reference and dereference things. And there's things these are all things that used to be a big deal. It used to be a large portion of coding and development, and it's sort of gone away because we've been able to protect ourselves from it, essentially, to build libraries that do all of that stuff for us. And I think just even pure functional coding is something that people just don't do, because you can do it. You can have functions in a lot of these languages, but they sort of just float around. You don't have it. They're mixed in with code and scripts and stuff like that. To have something that's got a little more structure, I think forces you to think through it a little better. And this all gets us to, if you're going to use AI, you need to be able to think through it. You need to be able to do the core things that are software development. You need to understand flows. You need to understand pseudocode. You need to actually think through top-down programming to some level of what is this doing, and then what does that do, and then how does that get done, and then how does that get executed, and doing those things. And something like a Rust is a great way to do it. Now, there is that itch for those of us that would be like, okay, good, I can put one more language into on my list of 400 languages that I know. And I don't know I don't think that's going to necessarily help you. I have said for a while, if you go back to the developer book even, it's really not about the language, it's about the styles of languages. So there is a very big difference between C and C++. Then there is JavaScript, then there is Python, and learning those types of languages, Lisp and schemes and Scheme and those kinds of languages. Learning those different language styles and types is very useful. Every one of them treats things a little bit differently, and being able to think that way is going to help you solve problems better. I think particularly when you get into the AI world, because AI sort of can allow you to sort of abstract from the language. So you need to be thinking about what are the different ways that I can solve this problem and which one works best in this specific case. I will pass it back to you. Further thoughts?
Yeah. So getting away from Rust just a little bit, but the concepts that we talked about, the compiler, the memory management. So in the world of AI and LLM and large language models, we are having to, if you are building a private model or you're working on the models, these are all topics that you have to really think about. You're not writing into scripting languages anymore. You're not writing interpreters. You have to write compiled language code, machine code for these AI systems. Any large language model has to be written to the chip, because you have to maximize the process power, the memory power. Otherwise, AIs, the models aren't going to be very fast, they're not going to be very intelligent, and they're going to get clunky. So if you are heading towards a path of, hey, I want to stand up my own AI, or I want to learn more about machine languages, this is kind of an exercise in that. You go through and you start thinking about memory management. You start thinking about processing. And Rust may be a entryway if you've never done C or C++, but those are just some things I think about from our conversation with them. It's like, yes, Rust, another language. This does sound cool, but at the same time, I'm thinking I'm fighting with my personal language models I'm trying to deploy locally, and you have to go through all those things. You have to work with the models. You have to make sure it works on the right machine. You have to go through all these tweaks, and I think we're heading back, at least from a developer's perspective, we're heading back a little bit, a couple of decades, where we have to be more conscious of this because we've lost this. I mean, I remember in 2002 going to an IBM conference and them talking about memory management. And this was like early Java days. And now we don't really talk about that at all anymore. You worry about your heap stacks and things like that, but it's so easy to just increase it in your VMs or AWS. You just increase the containers and you forget about it. I think we've gotten lazy. I think this is going to help us get back from being lazy and be more conscious and focused on this.
I do think that this is like, there was always the option of you could fix it in software or you could fix it in hardware. So you could buy bigger hardware, bigger storage disks, more processors, more internal memory, things like that. You could find a way to do that and solve it that way. Or you could solve it in software and find a way to write it so that it takes less space, works faster. I think that, yes, we have, especially in the world of like web applications and things like that, we really often don't care about how much time is spent on the server as much as we care about how much time is spent getting the data from the server to the end user. So it's really more about network speed and amount of data and some things like that. And there's some front-end processing obviously that goes on a little bit as well. But I think we've gotten away from some of these core concepts. And that I think is where we need to focus more, is that we need to get back to it, because I don't know that we're necessarily going back to where it's going to be needed, but I do think this is one of those that goes back to AI showing up the cracks, is that I think these are cracks. I think our lack of caring or knowledge of performance tuning and memory management and some of these other like core concepts, I think this is a crack. I think this is where we have lost this as developers. And now as we're getting into this AI world, and we're able to deploy stuff incredibly fast and incredibly big, and we've got data lakes and all this other stuff, and we're trying to scale applications like we never have before, the performance things we're going to hit those walls, because you can for a little bit, you can have stuff like everything is in internal memory and it just flies through it because it's there. But as soon as it has to hit a hard disk, bam, you suddenly have a very big change in your response times. These are kinds of things we need to think about. We need to not just say, okay, I'm going to query everything and it's going to bring it all back and then we'll just find a way to sort through it. It needs to be like, we need to be focused on what is our query? What do we want to bring back? How do we sort it? All that kind of fun stuff. And I'm not just talking databases. I'm talking any way that we're getting a hold of our data, that we're interacting with our user. All these things that we sort of got for free, we didn't actually get for free. Nothing is. And this is where I think we figure out, look at the cost so that we can better create our solutions for moving forward. Before I throw it back to you, I think that the challenge this week I want to throw out is to take a look at your code, what's your latest thing that you're working on. And I think we'll use AI with this one and show the cracks in your code. Is use it to say, just write a little prompt with your code, your little script. Don't give up anything, intellectual property or proprietary or private or anything like that. But just analyze it and say, how can I do this faster? Or, take a look at it. Where's it going to break? Is it going to scale? How is it going to, can I make this tighter, faster, smaller? What sort of footprint should I expect from this? And then just see what comes back. Because I think just going through the exercise of looking at what you did, and this isn't any language, there's probably going to be some ways that you can improve your code from a performance point of view. And I think this is an important thing to take a look at. So what are your thoughts on that?
I like the challenge. I would take it one step further, especially if you do want to touch on the Rust. take whatever language you're using, Python, Java, whatever. Write a simple program like list loop or something that takes memory. Try to do the same thing, small application in Rust. Add a timer to both of them so you know how long it takes to run, and run them side by side. Run it on machine language and then run it with the VM. See how much time difference it is, and then use like a profiler, because I know Java has one, I believe Rust does too, to actually monitor your system memory as they're running. And I guarantee you'll see a difference between the two.
I love that one. I love that as a phase 2. So everybody that's worried about they have too much homework, it's Michael's fault. But I love it because you can, and honestly, what I would do, I did this way back, was a very interesting little thing I did back years and years ago. Is I had a Linux machine and I had a Windows machine, and it was a little C script, and I ran this thing on both of them and timed it and all that kind of good stuff. And I think you guys can do the same, and you will see a difference in the languages, and maybe do 2 or 3 different languages. If you do something simple, like Michael said, like create a CSV, have AI create a CSV with, I don't know, 10,000 records in it, or 100,000. Pick just pick a nice enough, not 100, not 1,000, something that's a bigger number that's going to take a little bit, and then create a little script that processes it, does something, I don't know, goes through everything, and then, tells you how many characters are in each string or something like that. Just something that's nice and simple, and then do it in Rust. Have an AI will help you with this, or go figure it out if you want to learn Rust a little bit. How do I do this in Rust? How do I do this in Python? How do I do this in C? How do I do this in JavaScript? PHP, whatever, pick your language, Ruby, I don't care what it is. Pick about 2 or 3 languages, and exactly like Michael said, run it and make sure that you've got within it, like put some little, you don't have to even get crazy. You can just put little things that are timestamps that it took X amount of time. Here's where I started to load it. Here's where I finished loading the file. Here's where I started processing. Here's where I ended processing. I think this is the kind of stuff that will help you see with a real world example, the kinds of differences we're talking about here. So love that and if you only want to do one, do the second challenge.
And one caveat to that, make sure you do it on the same machine, because there's other factors involved. I don't want to get into them, but if you try to do it on 2 different machines, if you don't have the same hard drive, the same hardware, you're going to get different results. So just, if you do this challenge, do it all on the same machine.
So yes, you have to. Everything is the same except for the language, as far as you can, and that's exactly what I said. Is I had a machine that had it booted. It was the same hard drive or same physical machine, ran Linux, ran Windows, ran the exact same code in both of them. Everything was the same except for different operating systems, and I had very different response times. And this is what you're going to do here: is you're going to have everything's the same except for different languages. So, excellent. That's a very critical point as well. Don't just create a bunch of VMs and just say, okay, I'm going to do all of these. Run it all as best you can in the exact same operating system, same environment for each of them. See what happens. Love to hear from you. What do you find is the best, and what do you find is the worst? I would love to see that kind of stuff come back to us, just so we can figure out, and especially if there's differences between on the file load versus the processing and things like that, because I bet you will find that there are differences there. Big breath. That being said, it's time for us to let you get away, head out for your vacation, for your weekend vacation. Don't be a hero. We talked about that a week or 2 ago. Go out there and enjoy your weekend. As always, have yourself a great day, great weekend, and we will see you next week.